Hello, everybody, and welcome to another Agile IT Tech Talk. I'm your host, Sean Spicer, and today we're going to be talking about Microsoft Defender ATP. Now, last Friday, I got a new computer, really kind of built out one of the Republic of Gamers PCs from Asus, and slapped in new RAM, put in a nice RTX video card, and as I'm going through setup, I realized that it came with McAfee. And it's been a joke if you've been in the IT sphere for any period of time. The McAfee used to be almost impossible to install. And I thought we were going to do a tech talk today on me getting that crap software off my computer. This was such a joke that about 7 years ago, John McAfee himself did a video on how to uninstall McAfee from your computer. And this was his solution. The video is definitely not safe for work. It's not anything I'm going to share. But of course, I did opt to go with Microsoft Defender. So one of the other upgrades I did was go from Windows 10 Home to Windows 10 Pro. I don't have all the enterprise power, but thankfully through work, I do. In all of the Gartner quadrants and Forrester case studies, Microsoft is now the leader of threat protection, antivirus, anti-malware. And we've done a number of talks about this in the past, but I felt it was time to come back and do this again. The last time we really touched upon this product was a little over a year ago with Andrea Fisher. It was a great tech talk, and it was just prior to them rebranding Windows Defender ATP to Microsoft Defender. And what was fun about that tech talk, and you'd only know this if you were in it, is that she did a section where she talked about the advanced threat hunting capabilities in Defender, and then realized that they weren't released yet and nobody had seen them. So I had to go in and edit out that section of the video, and it's one of our most popular on YouTube. However, there are a lot of comments of, why does it skip out? Why does this happen? And I tried to explain it, but it's very hard to understand that sometimes when we have these tech talks and we have Microsoft architects or engineers join us, we are in an NDA environment, and we can't put that up on YouTube. If you are watching on YouTube right now, give us a like and follow. I guarantee you this one is for full public consumption, and we will not be cutting anything out. So the great thing about Microsoft Defender is that it's already built into Windows 10. It's not bolted on, so there's nothing to deploy. It's part of the operating system. So all it requires is to run a small onboarding script on each of the endpoint machines in order to onboard them onto the enterprise services. Machine management and onboarding. So the script sets the registries on the machines to report activities to the Microsoft Defender ATP service. There's no agent to install or run on these machines. Besides Windows, ATP can onboard and monitor non-Windows components, including we've got Linux, Mac, iOS, and Android. We're going to do Windows 10, and then we're going to deploy with local script. Now, you can also do this with whatever method is convenient for your organization. So you can use SCCM or System Center Config Manager, which is currently kind of moving into conjunction with Intune and is now known, or is now going to be known as Microsoft Endpoint Config, or Microsoft Endpoint Manager. So you can do this with MDM, you can do it with Intune, group policies. We're going to do it with the local script. So here in the Microsoft Defender ATP dashboard is an operational view of your organization's endpoints and users. So that gives your SecOps team an aggregated view of the latest alerts, their severity, and when they were observed. So you've got here, you've got the active alerts, you've got active automated investigations, automated investigation statistics, machines at risk, and users at risk. We scroll down a little bit. It also provides a listing of all the machines most at risk, with several alerts related to each machine, indicates the users at risk, providing insights into the activities, actions, and relationships. And these relationships are really cool. We're going to go into that in a little bit. The Security Operations Dashboard in Microsoft Defender provides a single pane of glass and centralized management. And ATP applies correlation analytics and aggregates all of the related alerts and investigations into one incident identity. I'm currently going through the Microsoft Azure Sentinel trainings right now. I do not have a lab to demonstrate it yet, but I will be working with them to get one. It is really cool, and it ties in and can be linked to MDATP. So alerts are any security-related incident collected from any of the organization endpoints that are then flagged by the service. And by doing so, ATP narrates a broader attack story, allowing your SecOps team to understand and deal with complex threats across the organizations with visuals. So a SecOps user can see the latest alerts from all the machines that are onboarded, along with the severity of each alert. Now, severity in this context is the potential impact the associated malware may have on an organization as a whole, not just to a single endpoint or single user. So dropping into the incidents queue and selecting an incident, let's look at weaponized doc, allows you to see where an alert, where a PowerShell dropped a suspicious file on an end user's machine. Let's see. Now, it's marked as a medium severity alert. However, the SecOps team wants to understand the context and see what actions we might need to take. So here you can see the command line where that was deployed. And that gives you a general idea, but it also allows your SecOps users to set the alert status, classification types, or create rules to suppress the alert next time it occurs in a specific machine or anywhere in the organization. So this alert process tree here takes alert triage and investigation to the next level. It displays the alert and related evidence together with other events that occurred within the same execution context and time. This rich context of alert and surrounding events is available on the alert page. Tracing down the malware related to this alert, SecOps can see that PowerShell was used to schedule an unusual task to run an unknown executable on the PC. So here you can see where you can manage your alerts. You can view machine timeline, open incident page, print alert, consult a threat expert. Now, looking into the alert process tree, the SecOps user can see that the file that was dropped is called WinATP intro backdoor, and the file name sounds suspicious, but we don't know yet if it's truly malicious or not. Now, the SecOps team can easily find out more by visiting the detailed file investigation page, and exploring the incident graph. The SecOps user can see how this incident has affected the entire org. So here we can investigate the details of a file that are associated with a specific alert behavior event to determine if the file exhibits malicious activities, can identify the attack motivation, and understand the potential scope of the breach. And let's do a deep analysis here. So to enrich the data related to the file, SecOps can submit the file for deep analysis. We're going to look at behaviors. So the deep analysis feature executes a file in a secure, fully instrumented cloud environment. So basically a cloud sandbox. Deep analysis results show the file's activities, observed behaviors, associated artifacts like drop files, registry modifications, and communication with IPs. So when malware may be communicating back to a command and control server. So let's go ahead and see who they're talking to. So here we've got the time, we've got what the process ID was, it's always service host, the target IP, so here it's IPv6, here we've got a communication a minute later with an IPv4, details UDP, TCP, and whether that communication was successful. So Here we can see that the suspect file makes this system file talk with an external IP address. Now, the observed in organization section, pardon me, provides details on the name of the file as it's observed within your organization and its prevalence in specific user machines. So we've got that tab up here, but let's do this. So attackers don't need to inject a physical file in a victim's machine to take control anymore. Attacks more often are happening through scripts. A user may be tricked into executing a script, or the script may be executed remotely from another machine in the organization that was previously breached, with the attacker attempting to move laterally within the network. Detection of these scripts is difficult because administrators also often run scripts remotely to carry out various administrative activities. Oh, I lost my mouse. So let's go ahead and look at someone's computer. Let's look at Andrew's, and we can see here the risk level is high. And let's look at the alerts here. So 10 active alerts and 1 incident. Something's going on here. So suspicious process injection observed. And you can see I've got malware installed, PowerSploit, pane, Mimikatz was detected. This guy's a mess. And then you can also see the status of your investigation, and these would be your own set classifications. But let's go ahead and take a look at this process injection. And what's nice here is even if you aren't a security expert, maybe you're level 200, you know a little bit about malware and how things move, how lateral movement occurs. The description explains why this is bad. It's no longer just that raw warning. So during automated investigation, Microsoft Defender ATP identified the Notepad.exe process, pardon me, which was injected into as one of the artifacts requiring remediation. And that's all listed out here. PowerShell command, exploits. Let's close this. So by default, Microsoft Defender will wait for your SecOps team's approval before proceeding, but you can also configure it under the machine group settings to skip this step and apply remediation automatically. So this would be done under automated investigation is waiting for user approval right here, and then we can click and investigate it. This is the view earlier that I was a little bit excited about. So this is the investigation graph, and then what you have here are the entities that are analyzed. But first, before we get into how this all works, because this is a really cool way to investigate, let's look at the pending actions. And we've got a list of files suggested for quarantine. So this is all of that different malware. You've got a keystroke logger here. Here's Mimikatz, the lib file, the drivers, PowerSploit. This guy's probably an insider threat, I'm guessing, from this, if it wasn't just a demo. So then we can go ahead and look at the machine list. Now, the machine view page provides the team with an overview of security relevant details like logged in users, high-level machine statuses, and risk profile. Here they can also see that the Microsoft Defender Security Center supports multiple endpoint types. So you've got your platforms here. You can see you've got Windows 10, Windows Server down here. We've got Mac OS. And let's go ahead and look at one of these. So Lola's PC. So here we're going to take a closer look at a machine with an alert. And we're also able to see a summary of all relevant alerts on this machine. Again, this looks like it's Megan Bowen's machine, to take back that old demo joke that we've been making for a couple of years now. So additionally, you can view the rich and detailed timeline that shows all the events observed for the machine for as far back as 6 months. Additionally, you can interactively hunt, search, and explore historical data across all of your endpoints. Let's see, last activity. So you can sort by these columns. I'm going to go ahead and sort by last activity. And then we can go ahead and filter that activity. And you can reduce some of the noise by using this search and filter functionality. So let's just look at file events. That seems to be pretty prevalent in this environment. and we're going to go ahead and search for events that involve DOC files. And then let's look, WinWord.exe created this file. And here we can see WinWord created this file, what time it was taken, action type, and then the actual command line that was done to make it execute. So it is running as a script of sorts, but then we can look at the file and we have the ability to open the file. Now, drilling in, this detailed view of the alert shows your team what services were involved in the alert as well as what files were affected. Now, this is interesting because there were 8 email inboxes affected. This wasn't a single hit. This is hitting multiple inboxes. So let's go ahead and open that up. Now, here we can see that the malware in question was introduced via an email, and with this, with the deep integration between Microsoft Defender ATP and Office ATP, we can also get more details on who else in the organization received the email, including delivery actions, so whether it was delivered to junk, or blocked, as well as the delivery location. So did that go to the inbox, junk box, or did it go into quarantine? And here we have, pardon me, so you can see by the bars, we've got delivered, blocked, and delivered to junk. So it looks like most of it got delivered to junk. So let's scroll down. And here we can see the individual emails. I'm not going to go through all of these and see, okay, it was the same subject line, so this wasn't spear phishing, most likely. The sender, Juno.com, I didn't even know that was still around. And it was delivered, it was dynamic delivery, where it landed in the inbox folder. So then we're going to go back to the Microsoft Defender portal and take a look at our threat analytics. So cyber threats are emerging more and more frequently and prevalently. I mean, during COVID-19, it was insane to see the amount of new threats emerge within days of states going into lockdown, where there were false Power BI files being sent around where people could monitor new cases. It's constant, and it's a game of cat and mouse where the mouse just keeps running faster and faster and faster. It's critical for our organizations to quickly assess our security postures and cover the impacts of these emerging threats, as well as what is our organizational resilience against them. Threat analytics in ATP is a set of reports published by Microsoft security researchers as soon as these emerging threats and outbreaks are identified. And that's one of the powers of Microsoft. Windows is the most used operating system in the world. And Microsoft takes the signals from all of these endpoints. So whether you're running Microsoft antivirus or Windows antivirus on Windows 10 Home, or you're running Microsoft Defender ATP, or you're using these endpoints on Mac, these signals go back to Microsoft, and they're able to rapidly research and identify what to do. So these reports help your team assess potential impacts of threats to your environment, and then identify the actions you need to take in order to contain them. This really lets you stay one step ahead. And the threat analytics dashboard is a great jump off point for getting to these reports, and the reports that are most relevant to your organization. It provides several overviews about the threats covered in these reports. You've got latest threats, you have and these are the most recently published threat reports, whether they've touched your machines or not, along with the number of machines within your organization that have resolved or unresolved alerts. You've got high impact threats. These are the threats that have had the highest impact on organizations in terms of the number of machines that have had related alerts, along with the number of machines with resolved and unresolved alerts. Very nice to see one encrypted 0 in this environment. That's not a fun one. And then threat summary. Threat summary just shows the number of threats among the threats reported in threat analytics with actual alerts. Let's go ahead and then we can dig in deeper on all of this. Now, living off the land binaries. So every threat report generally provides an overview of the threat and analysis of the techniques and tools used by the threat. It also provides worldwide impact information. mitigation recommendations and detection information. It includes several cards that show dynamic data about how the organization is impacted, and then how prepared it is to stop the threat. Now, these cards are designed to provide information about the organizational impact of these threats. So you've got machines with alerts, shows the current number of distinct machines in your organization that have been impacted by the threat. And a machine is categorized as active if there is at least one alert associated with that threat, and resolved if all the alerts associated with the threat on the machine have been resolved. So if you have 6 alerts on a machine and you have 5, it's still going to show as active. You have to resolve all of these alerts. Now, it will also show machines with alerts over time. And so this shows the kind of growth of these threats. And the number of resolved alerts indicates how quickly the organization is able to respond to alerts associated with the threat. And ideally, this chart should be showing alerts are resolved within at most a few days. So each report includes cards that provide an overview of how resilient the organization can be against a current threat. So what is the mitigation status? This shows the number of machines that have and not applied, that have and have not applied mitigations for that threat. Machines are considered mitigated if they have all of the measurable mitigations in place, and I kind of mentioned that a little bit early. Vulnerability patching status shows the number of machines that have applied security updates or patches that address vulnerabilities exploited by the threat. And then mitigation recommendations lists specific actionable recommendations, pardon me, to improve SecOps visibility into the threat and increase the organizational resilience. This card lists only measurable mitigations along with the number of machines that don't have these mitigations in place. So let's look at the threat and vulnerability management here, and we'll go a little bit deeper. So the threat and vulnerability management, we're going to call it the TVM component of MDATP, provides real-time endpoint vulnerabilities and misconfiguration assessment for both operating system and third-party software, prioritized by and correlated with external threat landscape insights, so signals I mentioned earlier, internal threat insights, so that's your EDR context, and business context. TVM also includes the ability to create remediation and mitigation requests and monitor their progress in real time. So that bridges the gap between security admins and IT. Here in the MDATP Threat Vulnerability Management Dashboard, this is populated with several key overviews. The following data provided helps enable your security team. So your exposure score. I love these scores. Having been working in systems for a long time, having this visual representation and a score just makes things really easy to see your progress. And we did do the previous sessions on, pardon me, I'm gonna need to take a drink of water here. So we did do the secure score sessions where we attempted to get a perfect secure score. It turns out it did not work in a demo environment. We needed to onboard machines, and we couldn't do that with the demo, but still, it's a valuable tool, and it was great to go through all of the different settings. So then your configuration score reflects the collective security configuration posture of all your machines across every OS, applications, networks, accounts, security controls, and you can increase this configuration score by addressing these mitigation suggestions based on priority. Now, configuration score serves as the Microsoft Secure Score for devices. This score and its related configuration assessments comprise the device pillar in Microsoft Secure Score. So then exposure distribution reflects the exposure level distribution of machines in the organization. And then just like Secure Score, we have top security recommendations. So these are probably the most important things that you need to do. So your top security recommendations are prioritized based on the dynamic threat landscape factors. So you're getting outside signals for that, but it also has the breach likelihood, the business context, and machine value. So if this is on your marketing guy's computer, I like to pick on the marketing team, it's going to be lower than if it's on one of your servers or a person who frequently logs in as a global admin. And then it's also going to have bring in signals regarding associated threats and public exploits. So if there's a proof of concept that's up on GitHub and every code script kiddie in the world can run this, it's going to move up in terms of that impact and how high that's going to be in one of your top recommendations. So let's go ahead and scroll down here. So then we've got top vulnerable software, WinRAR. Nobody ever registers WinRAR. So your top vulnerable software gives you real-time visibility into all of your organization's software inventory with a stack ranked list of vulnerable software installed on an organization's network devices and how they impact your organizational exposure score. You can also drill down into what the weaknesses are and get more detailed information. Your top exposed machines. You can see the machine names and their exposure level. Your security team can click on each machine name from the list, and it will take your SecOps user to that machine page we looked at earlier, where they can view the TVM context for the exposed machine. They can see the security recommendations, what software is installed, discovered vulnerability, and missing updates. And then remediation activities. Track your remediation activities generated from the security recommendations. So these are what you are doing and what you should be doing. So it gives almost like a ticketing system. So let's look at some security recommendations. So diving into these security recommendations, you can see that MDATP is providing a list of actionable recommendations to improve the vulnerability posture of the organization, both in relation to software vulnerabilities as well as endpoint misconfigurations. The page contains a dynamic list, and it's prioritized, of security recommendations for the entire organization, across all operating systems and software. These recommendations are prioritized based on that potential exposure we discussed earlier, and then the improvement impact that applying them would generate to help your security admins focus on the vulnerabilities that are currently posing the highest exposure risk. So let's look at update RAR Lab WinRAR to version 5.8, and we'll look deeper in this. So by clicking on a recommendation, your team can view further details about the recommendation, such as exposed machines, related critical vulnerability exploits, etc. So, and we can go to date. There we go. So to complement the scenario described in the earlier section in reviewing security recommendations, the next step after reviewing a recommendation is to apply the mitigation. So we've got remediation options. Well, you do not have the necessary permissions to submit a remediation request. Contact your administrator for details. So there are two types of mitigating actions that can be taken. You can create a remediation request, which is the primary mitigation option for a security recommendation. And we can make exceptions. So creating an exception, in some cases, it's not possible, like we saw, to apply the primary remediation, and security admins can choose to create an exception instead. So here we have the TVM view of the remediation. So this area of TVM provides the ability for you to view, monitor, and manage the progress of remediation requests and exceptions that were created within your organization. So let's look at that update WinRAR. So the remediation progress is a real-time reflection of the endpoint patch state that is continuously assessed by the ATP sensor. So there are 0 active exceptions on this one. So here you can view any activities that are currently active or in process, as well as expired and completed activities. The software inventory area of TVM provides visibility into all the first and third-party software installed across all devices in the organization. Here you can see the name, the vendor. Windows 10 got 75 weaknesses. That's spooky. So here you can see with Threat Insights a Local privilege escalation exploit is publicly available for one or more weaknesses related to the software. You can filter over here on your weaknesses. Are there any, has or no known? And this page provides a list of all the first and third party applications that were discovered by TVM across all your devices, ranked on exposure. And then this allows you to drill down into any of the software products listed for a detailed overview of that software and its related TVM information. So that's going to have your security recommendations, exposed machines, related vulnerabilities, version distribution, missing security updates, and more. So this is a tool. This gets a little bit more powerful even than just antivirus or malware. You can see where your version drift is starting to occur, where there are machines that haven't been updated, and you can identify them right down to the machine level. So this page provides all of the available information related to the vulnerabilities that particular software is introducing into the organization, their exposure impact, and then your related security recommendations. So a list of all security recommendations related to your software is available here in security recommendations, but let's look at discovered vulnerabilities. So your discovered vulnerabilities tab gives you a list of all CVEs that exist for this software across all your machines in the organization. And you've got the CVE here, what the severity is, and then we can see where this software is installed. That's a terrible name there for a Win 10 machine. So this is a list of all the machines that have the software installed. So now you can start to come up with a plan. With Windows 10, thankfully, you can manage it through Intune. But if this was something like WinRAR, where you need to go through everybody's machine and click, and fix, you can start to create that plan based on where things are installed. So in version distribution, we get to see which versions are installed, how many computers they're installed on, and then what the discovered vulnerabilities are. So here we have a machine that's running 18368, so that's pretty old, that has 75 discovered vulnerabilities, but thankfully it's just one machine. And then missing KBs. So the missing KBs tab gives all of the missed security updates for the software. So it looks like 1909 was not installed on that machine. And it also has a link to the knowledge base article that explains what that security update is. So let's go back to the dashboard here. Now the machine page in ATP has been enriched with all the TVM data, including full vulnerability context for the machine, security recommendations, software vulnerabilities, software inventory, the missing updates, and overall exposure level. So this is your single pane of glass. So here we can look at top exposed machines. Let's see what Deborah's going on here with 482 vulnerabilities. So this enrichment serves your SEC team, who can now easily see gaps in all of your machine defenses while investigating an alert and gain insights into possible weaknesses that were exploited by an attacker. So this is the list of all of the TVM recommendations related to the machine. Here is all the software that is identified as installed on the machine, along with your weaknesses, threats. Here are all of the vulnerabilities. This is all 75 of those vulnerabilities that were identified on the machine. Go figure, Acrobat Reader. And then a list of all the missing security updates. So there are no missing security updates for the Windows 10 for this particular PC. They're actually just weaknesses based on the software that's installed. So we can come over here and look at organizational weaknesses. So the weaknesses page is essentially a knowledge base listing all of the CVEs that are known, both CVEs that apply to your organization at this time, as well as those that aren't. So your security team may be interested to understand how exposed the organization is to particular CVEs. So if you're out there and you have an active security team that's keeping up with things, they probably see when these CVEs come out. And okay, real quick, this is a bad one. This allows malware to come right in. We're subject to crypto lockers, whatever the case is. You can come in and look up the CVE And for each vulnerability, you can view the severity using the Common Visibility Scoring System, the CVSS. This includes the vulnerability description for the CVE, as well as its prevalence within the organization, any related software you have, or a corresponding breach. So let's take a look at what that looks like. So now we can review the vulnerability details, which include detailed information on the severity, the age, and any known related software. So we've got the vulnerability description and vulnerability details. And then when we scroll down here, we also have access to detailed threat insights, which includes information relating to the threat landscape for this vulnerability, such as public exploits, exploit kits, and then you've got the threat insights that carry that. And then we can look at exposed machines. So with endpoint management, you have detailed data as exportable on any of your exposed machines that have this particular vulnerability. Now let's go into the fun part. So one of the great things about Microsoft Defender ATP and then the TVM integration is the advanced hunting capabilities. And this makes me happy to just see, let's start hunting. It makes me feel like I'm going out and going to catch some hackers. So we can look here under the shared queries, and we're going to look at TVM, and we're going to look at vulnerable machines with alerts. So here we have a saved query for identifying machines that have an active high alert status for software threat vulnerabilities. You're then able to run this query to see what machines in the environment need remediation. And these tie into the Sentinel playbooks. And once I get that Sentinel demo, you guys will get to see that. So right now we can run the query right here from the dashboard. And the results are great for the operations team. There are quite a few machines here that need attention. And so we can go ahead and see what we can do with these alerts. So let's look at Lola's PC. And on this alert window, again, we can see how the vulnerability in software has allowed malicious activity. Pardon me. Then we can look at the actions. So under actions, we have the option to consult a Microsoft threat expert. If your team chooses to submit a request, a Microsoft expert would come in and review the alert and then give detailed recommended actions for remediation. And that's right here. We're not going to do that. So the TVM, the Threat and Vulnerability Management data, is also reachable via the global search option of MDATP by choosing one of the TVM entities. So you've got vulnerability, software, and recommendation. I'm missing it. There we go. So here we can look at machine, file, user, URL, IP, vulnerability, software, and then by recommendation. Let's go ahead and look at the software, and we're going to search for Adobe. So the TVM software inventory page will open showing a filtered view of Adobe software, and we can see the selected machine groups there. And so here you can, the TVM pages can be viewed by context of your specific machine groups. This provides the ability to understand what vulnerabilities and exposures are for different parts of the organization. So let's look at the semi-automatic machine groups. So the machine group filter remains persistent when moving across and drilling down through different TVM pages. That's important to remember because you will have to clear your filters if things start to show up empty. So here we can look at the machines list. So the live response is a capability that gives instant access to a machine using a remote shell connection. It gives you the power to do in-depth investigative work and take immediate responses to action to promptly contain identified threats in real time. So let's go back to Lola's machine. So the live response is designed to enhance your investigations by enabling your security teams to quickly correct forensic data, run scripts, send suspicious entities off for analysis, remediate threats directly in the platform, and proactively hunt for emerging threats. I am going blind. So here we're going to initiate a live response session. So connection currently active. So you can type help to get this initial menu of everything available. So we're going to find Notepad. We've got the path to Notepad exe, and you can see we've got something a little bit different there. And then we can look at command logs. So here we can see what commands were done for the investigation. And then we can look over here to the Action Center. And while this example walks through investigation or remediation of a benign file Notepad, SecOps users can use this live response tool to scan, analyze, and act on any file or process running on the organization's endpoints, as well as seeing full history. So let's see, we've got live response commands, quarantine files. Let's look at a quarantine file. So in this case, we can actually undo what the investigations or what the actions were. So if this quarantines a file that shouldn't have been, you can undo that action. So it gives you a little bit more confidence in moving into that, oh, I don't know what I should be doing here. So before running a PowerShell script, first you upload it to the library. And if you're planning to use an unsigned script in the session, you're going to need to enable the setting in the advanced features settings. So in this case, we're going to upload a file to the library. We're going to choose a file. Let's see, documents, and get mini dump. Go ahead and upload it. We want to overwrite older files and confirm. Script was created. Now we can go ahead. So now we're going to go ahead and get that script. So this section, we're going to demonstrate how to use the third-party forensic tools to gather forensic information from an endpoint machine. In this example, the SEC team is going to demonstrate how to dump a master file table using NTFS info applet from sysinternals. So again, we're going to upload a file to the library. NTS info. I'm going to overwrite the old file. So master file tables are file tracking systems that are used in the function of the Windows NT filing system. Considered to be an important part of metadata files, they help define the volume of an NTFS volume. Often referred to as the MFT, the table houses information about every file and directory that is found in the file system. Here we're going to get the MFT dump script. Again, we want to overwrite and confirm. So now that we've shown how to initiate live response sessions and perform basic remediation, get a mini memory dump using a PowerShell script, and use forensic tools like sysinternals to acquire forensic information on a machine, the tutorial emphasizes typical scenarios and commands that are useful when an in-depth investigation and remediation is needed on a compromised device. So in this section, the security team is going to review a few Power BI reports that were built using data collected by Microsoft Defender ATP services and exposed through the MG ATP APIs. So typical enterprise security teams rely on dependable reporting visualizations to make critical security decisions, as well as to communicate that to executive leadership who may not understand impacts. So while Microsoft Defender ATP provides extensive visibility on the security posture of your organization through all those built-in dashboards, custom reporting can help turn security data from multiple sources into actionable insights to meet your analytical needs. So let's look at the ATP reporting group. So Power BI is Microsoft's business analytics service that delivers insights to enable fast, informed decisions. You've seen a few of our demos around this, and for our clients, I'm sure many of you have Power BI set up already to look at your own unique business cases. So the first example here is how about Power BI can be leveraged to visualize the MD-ATP Advanced Hunting API. And the second example we're going to do is going to demonstrate how a connection to the OData APIs to visually showcase what the machine actions are. So here in the Power BI homepage, there's a dashboard that contains some of our MD-ATP reporting data. So your SecOps is going to dig into this, and by clicking into the reporting group workspace where these reports are hosted, I keep losing my mouse. So inside this workspace, the SecOps user can see we have a pinned dashboard where the data is easily accessible. And here in the MD-ATP dashboard as well, we can see we have two reports being shown. The first one we mentioned earlier is the Power BI report that is leveraging the Advanced Hunting API, that they can then take a closer look at this report by looking at the event data. So in this report, we can see the Advanced Hunting query that was used to generate the report. In this case, it's pulling anytime MD-ATP action contained antivirus. So this is your single view of when viruses are touching your system. As you can see in the example, the environment is pretty busy. The report is a great way for the SecOps user to quickly determine if there is a rise in activity and what machines are most impacted. This report can be shared, exported, and even subscribed to as a feed, so the SecOps team can get this report directly into their inbox as part of their daily routine. It can also be shared out with any stakeholders that need that visibility that aren't directly part of your SOC team. Excuse me. The SecOps user is then going to head back into the Power BI dashboard and take a look at that second report that uses the OData, and that's this action count. So here in machine actions, we can see what actions, both manually initiated as well as automatically initiated, have been performed within the environment. It has a breakdown of these actions per machine, so you can see which machines are most active, which can aid in identifying if there are machines that may be compromised. And in this example, they can see that there's one active machine, and this would lead to the probability that this machine has been compromised. Like the other report, this report can also be shared, exported, and subscribed to. And again, this can be sent out daily, weekly, as part of whatever routine you want. And both reports have been configured to auto-fresh the data daily. So these reports are always up to date, allowing the SecOps user to be proactive. Microsoft Defender ATP is a platform to help enterprise networks prevent, detect, investigate, and respond to advanced threats. And with Microsoft Threat Protection, Microsoft Defender ATP, and all of the different Microsoft security solutions, all of these together form a unified pre- and post-breach enterprise defense suite that natively integrates across all of your endpoints, all of your identities, email, and applications to detect, prevent, investigate, and automatically respond to sophisticated attacks. Now, we have done sessions on Cloud App Security. We have done sessions on Azure ATP. We've done sessions on a real brief one on Sentinel. And what's nice about all of these different tools is that they're built in and integrated live. They aren't something you have to tie together with weird API settings or integrations. You don't have to get into RESTful, anything like that. They just work together. And knowing how to drive and operate these different tools and make sure that things are configured right sits within the tools themselves. And you can use these advanced capabilities to really create a more secure environment, no matter what endpoints you're using, no matter what your environment is like, and the tools are already part of most of your licenses. Thank you, everybody, for joining us today. As a reminder, Agile IT Tech Talks are a service for our MSP and CSP customers who are able to watch this live. After the session, we do a NDA protected Q&A where they can ask questions related to their own environments and get that input. However, if you are watching online, go ahead and ask any questions down in the comments. I'm happy to answer them. Sometimes it takes a little bit longer than normal because I am not an engineer. I'm just a happy nerd that likes to do all of these demos. But right now we're going to close it down. If you're watching online, give us a like and follow, and we'll see you next week.